Metrics is used to indicate which quality attributes, internal or external, are being measured and sometimes depending on how the metrics computed, observing the product or its effects. It was supposed that metrics would be defined to measure the quality factors of the model. The 1991 version of standards advocated the definition of a quality model as a hierarchy from a fixed set of characteristics to the attributes. Now, metrics are embedded in the model itself, attaching one or more for each sub-characteristic in the model. The goal question metric approach is one of the most widespread approaches in identifying and defining metrics. In GQM, goals of the product under measurement are identified, and then some questions are raised to characterize the way the assessment of a specific goal is going to be performed. Then, a set of metrics is associated with every question in order to answer it in a quantitative way. Note that metrics can be both objective or subjective. The final result of the GQM approach is a hierarchical structure in graph-like form, since metrics may influence in more than one question, and questions may be related to more than one goal. In order to allow a precise understanding of the standard ISO IEC 9126 and the refinement and enrichment proposals presented from previous clips, we have developed a conceptual model using UML class diagrams. This model gives an unambiguous and complete view of the quality framework and allows a precise understanding of all the enclosed concepts and relationships between them. It facilitates the construction of quality models and can be used as the basis for the development of a tool for supporting the quality model.
Every class in the diagram states a concept in the quality framework described. Relationships allow giving a precise view of how quality models are structured in quality factors. The class sub-characteristic are specialized into two subclasses, in order to avoid a specific sub-characteristic to be decomposed into both sub-characteristic and attribute at the same time. Therefore, a sub-characteristic is either decomposed into other sub-characteristics or into attributes. In conclusion, we have commented on some practical issues arising when using the ISO IEC 9126 quality standard. The main contributions of our work with this standard can be summarized as follows. The development of a conceptual model that defines in a precise way all the concepts that appear in the standard, both belonging to the Part 1 quality model and the other parts metrics. The definition of a methodology for extending the ISO IEC 9126-1 quality model. The extension of the standard with some non-technical factors to leverage all kinds of relevant criteria. The use of the goal question metric approach to provide a rationale to the definition of software metrics. The construction of tool support to make the development and maintenance of quality models and metrics.